All right. And we are
Kind of a complicated problem to do backwards.
dude.
It's just like KVL, KCL, you know,
Ah,
simple.
you're right. You're right. Yeah, go for it.
Like actually, they give you everything. Let's just solve it outright. Are we doing 7?
This one
Alright.
is number what? This is number 8. So,
Oh, so we're doing 8. We're starting off
right
at 8. Okay.
above it, yeah. So if you want to start on number 7, feel free. Or if you want to
Okay. So pull up the question. I'm not going to because like you guys have a copy of it. So,
Yes, sir.
so 7. You get voltage is going to equal what, 10K?
Voltage is 10 kilovolts, yeah.
Like that. I is going to equal 10 amps. And then R is going to equal 0.7.
R is 0.7, yeah.
Anthony, just I don't know if you did already, but since you're recording, make sure to pin Justin's thing.
Thank you, sir. I didn't know how to do that.
All right. So they're trying to trick you with this voltage, right? So you can just take it out because technically it's going to be a voltage drop across the line. So like it's not experiencing the full 10K.
Tricky like that?
Yep. Just useless information. So this is literally just Ohm's law. P equals I squared R. So let's see. 100, 0.7 equals what, 70?
And 70 watts is one of the options, and I believe it's the answer as well.
Good. No, this one's just like not getting tricked by the voltage, and that's about it.
Everyone?
If anyone has questions, moving on to 8.
Anyone have a question? Anyone have a question about it? Pretty straightforward.
Yeah, this one was pretty straightforward.
Or no? I actually added the thing so if anyone has a question, then if anyone has a question, they could raise their hand.
Something.
Or if they don't understand it, they could if they're ready to move on, they could put yes. If they're not, then no. So if you're ready to move on, you can just put yes. And you can be all good to go. Yes, yes, yes.
All right, cool. So the next problem, number 8, we're going to be looking for this one, IAE, which is right here. So like, how are we going to solve this? We can approach this like V equals IR. That's a really common one. Or in this case, like KVL, right? So you have 400 right here. And if you notice with all the givens, you're going to have your VE equals 100 volts, right? So if you have 100 volts over here and you have 400 volts over here in one loop, what does this one have to be? KVL, 300 volts, right? So from there, you know, plus minus 300 volts. Then you can do 300 over 10, 1, 2, 3, that. Did I do this right? Sure. 3 divided by whatever, that's going to equal 30 milliamps. Good, good. Should be pretty
Justin.
simple. What's up?
I was wondering if you can use like a darker pencil or a pen. I can't really read that. It's kind of light.
Yes, I can.
Thank you.
Let's hope I don't mess up.
A huge eraser.
Yes. I lose erasers like nobody's business. You gotta have,
Because I'm looking at the way the book did it, or the solutions for it, and they got your answer. I just don't understand how you got them.
All right, get good foot. Hold up, bro.
so,
Yeah, hold on. Okay.
Give me a second to process this.
right here. So if you like draw out number 1 or 8, this little loop right here, it's going to be plus minus. That's going to be 400, right? 400 right there, right? Then you can go here. Right there, and that's your isolated single loop. So we know that this is E right here, and this is F right there. So right here, it says VE is going to equal, that's ground, VE is going to equal 100 volts. So we already know positive, negative, positive, negative. This right here is going to be 100 volts. So when we do the KVL, let's see, rise is right here. So 400 is going to equal
Rises and falls are on opposite sides.
whatever, say Vx, right? Vx plus 100. So we know Vx is going to equal 300 volts. Right? So far? Then this right here is going to be 10K ohms.
Then V equals IR.
Exactly. I have it right here. 300 volts over ohms is going to equal 30 milliamps.
I didn't know you can just take out all the other resistors like that. I guess it's only asking for one for one box. Oh. Damn. I get it. Simple enough.
Now, is that the right way to do a check mark?
Yes.
Okay, cool. Okay, so we got that. Now we have to find IBE, which is the second one, which is going to be this one. This one's even simpler because it gives you the voltage right here. Voltage is going to be 300 volts. IBE is going to be 5K. So you have everything. 9. So we have EBE over 5K ohms. It's going to equal 300 over 5,000, 1, 2, 1, 2. It's going to equal 60 milliamps. Sixes are hard in reverse.
Those resistors, you're making your own plus and minuses for them, right? That's why you did VBE over 5K equals instead of like plus.
Oh yeah, I'm following passive sign convention because this is plus minus, right? Plus minus over here. So just so breezy is like when in doubt, current goes from minus to plus, so it just goes this way. And then whatever side hits first is going to be the plus. So it's this first, that's going to be plus. Other side's minus. Hits this first, that's going to be plus, minus.
Thank you.
Yep. Yeah, guys, feel free to stop me anytime or like go back to other problems. I like to go through things kind of fast if you guys are silent.
I'm just trying to see right now which all the work, but
This one. All right. What's next?
voltage 100 PE.
Chat. Okay, Felix. All right. So moving on to number 10, right? We're trying to find IEF, same exact process. They give us VE right here. So we have the voltage. We know the current's going to be 1K, right? So I think this is 10 or 10. We can go VE over 1K equals 100 over 1,000, cross, 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 cross. Ends up being 110, 100 milliamps. Okay, number 11. Now this one's a little tricky. This one has to do, you have to do KCL at this node right here, but it's asking for power emitted from this source, right? So as we know, P is going to equal to IV. We have the voltage. V is going to equal 400. So now I need the current. So we know that the current going in to this node that's leaving from this source is going to equal this current we already found plus this current right here. So what is this current? This current is going to equal to this current, which is given, plus this current that we found, right? We already found earlier that IBE 60, right? And this IBC is going to equal 100 milliamps. So we know that this I, let's say, sub x, I sub x is going to equal 60 plus 100. It's going to equal 160 milliamps. IX. And the I we want, capital I is going to equal IX plus this one right here, plus IAE, which we found to be 30 amps, 30 milliamps. So I is going to equal 160 plus 30 equals 190 milliamps. So now that we have that, we can plug it into this equation up here. So 400 times 0.19 is going to equal to, what is that? $76 watts. Is anyone?
Yeah, just give me a second. I'm copying. I'm looking at the calculations and everything. Thank you, Justin.
Got it. Leave that there.
How did you find IBC again?
That was given.
Oh, it is. Oh.
Yeah,
Okay.
right down here.
Thank you.
I think you're muted, Anthony.
I was muted. No, you're muted. Yeah.
Wait, what were you saying?
I was saying, if you need more time, say yes. If not, say no.
I think Matthew's up next.
Yes, sir. Matthew's due number 12.
Yeah, number 12, right?
Yes, sir. Yes, sir. Everyone okay? Not getting.
So what is this one? Finding, this is using the same circuit that, for the problems that Justin was doing, right?
Yes.
Cool.
Keep in mind that Justin was writing backwards that whole entire time.
Yeah, I don't know how you did that, bro.
I don't even know how.
That's insane.
That's how big of a brain.
Yeah,
he
I was
has.
like,
He
he's
can
not a
just
lefty.
Write backwards.
Yeah, no, it was all backwards because it's mirrored on his screen.
Yeah, Ken, I couldn't figure it out. I gave up.
Yeah.
Is a psycho, dude.
Brain.
Can you guys see my screen?
Yes.
Yeah,
Okay,
it's good.
Justin. Big props.
All right. So now, Matthew, floor is yours, my dude.
Are you guys ready?
I believe so.
I'm ready.
Okay, so this problem is asking us to find this value of RT, this output resistance. Now, just by looking at this, we can tell that the current going through that resistor is going to be equal to that current IBC, which is given, minus the current going from node C to node B. So that's the first step. We need to figure out what this current is through RT so we can find its value. So this is going to be ICG is equal to IBC minus ICD. And as I mentioned, IBC is already given. We can find ICD just by using simple Ohm's law. So our current is going to be equal to the voltage drop across that resistor divided by that value of resistance. So VCD over R. So this is going to be 100 milliamps minus 200 volts, which is given, divided by 10 kilo ohms. So that should come out to 80 milliamps. Okay, now that we have the value for the current flowing through it, we can use simple Ohm's law again to figure out what that value of resistance is. So by looking at this, we know that the voltage drop across this resistor is going to be equal to our input voltage, just based on KVL. If you write a KVL for that output loop, you'll notice that that voltage drop across it is the same as our voltage across the battery. Give me a second, guys. My screen is freezing up on me. All right, so our battery voltage is equal to 400 volts. So the value for our output resistance is going to be that battery voltage divided by that current flowing through it that we just found. So it should be 400 volts divided by 80 milliamps. That should give us a value of 5,000 ohms, which is equivalent to 5 kilo ohms. Anyone have any questions how I did that? Anyone want me to explain anything?
Mm-hmm. Let me see.
I think people are just copying right now, I believe, or not copying, but yeah, copying.
Yeah, so we'll give it a couple seconds before
Yeah.
I move on to the next one.
Yeah. Let me see.
This is a fat problem. All right. Anyone have any questions for him, or like I said, yes in the chat, yes in the participants window to move on, no to not move on.
What was that, Anthony?
No, I'm just saying yes if we're yes in the participants if everyone understands it and ready to move on. No if they're not ready to move on.
Yes.
Yes. Okay. All right. Everyone looks like everyone understands it. Good job explaining it.
I'm gonna move on to number 26.
No, we're actually gonna we can actually just go by numbers, no? Or do you want to just move over to 26?
Well, I mean, that way we don't have to keep switching between who's sharing their screen.
Oh yeah, that's true.
Like,
Go for it.
like now Justin ran through a couple, and
Mhm.
I mean, I think that would be easier. But if you want to go in order, we can do that.
Say less, bro. Floor is yours. Number 26.
Who wants to go in order, and who doesn't really care?
I'm good. You can do it, Matthew. Fuck it. You already
Yeah,
sharing your screen.
You're already on
I'm
screen.
sharing my screen. Already sharing my screen. I'm just gonna do number 26. All right. So this one is asking us to find equivalent resistance seen by the battery. So they give us this circuit here. Okay, so they give us the circuit and ask us to find the equivalent resistance seen by the battery. All right. So the first thing I noticed when looking at this is that we can actually move this connection right here. This is one big node. So we can just redraw this circuit to make it a little more obvious as to what our next step should be. All right, so does everyone see what I did there? All I did was redraw the circuit. This node is still connected here. All we're doing is, reshaping it essentially. It's not changing how the circuit is physically connected. So we just shifted this node over a little bit to the right. Okay. Now looking at this, we have a very obvious parallel connection here. So this is going to be 7 ohms in parallel with 6. So this should be about 3.23 ohms for that parallel combination. Okay, so now we're going to redraw the circuit again. Now another thing I noticed is this 2 ohm resistor here at the bottom. We can slide this up here without changing the physical connection of the circuit, just to make it easier to work with. So now by looking at this, we can see that we have a series combination here. And whatever that gives us is going to be in parallel with this 5 ohm resistor. So we can find our equivalent resistance by adding the 3.23 ohms plus 2 ohms, that combination in parallel with 5 ohms. So this should give us about 2.556 ohms. Everyone clear on what I did here?
Yes.
Yep.
Yeah. Very straightforward. Yeah. Mm-hmm.
Get it? It's moving around. Moving around nodes.
Mm-hmm.
No one needs more time for this. Everyone's good. So we're gonna jot a couple things down. Everyone's
Give it a
good.
couple more seconds.
Yeah.
I think we should go back to going in order instead of jumping around.
You want to go back to you
Yeah.
want to Sebas?
So which one did we leave off? I think the last one I did before this one was 12, right?
Yeah.
Yeah, so let's just let's go in order from there.
So we'll just move on to Sebas then?
Yeah.
Okay.
All right. I'll
That
share
can
my
we tell us?
screen. Yeah. You got to stop sharing your screen so I can share mine.
Yep. It's all yours, buddy.
All right. I'm incoming. Okay. All right. Hello, everybody. Here we go. Let's do it. Number 13. So here's the question, just in case you don't have it, but everybody should have it. So here we go. The question is asking, all circuit elements are ideal. The circuit is steady state. Okay, so we got these 3 questions to answer right here. All right, first one we're gonna do is 13. What is the current flowing flowing through the 3 ohm resistor? So in that case, it's talking about this one. All right, so let's redraw this circuit. Okay, the very key thing to take away from this is that it says the current is at steady state. So when that happens, we have to treat a bunch of things very differently, okay? So you might get intimidated, see that there's a capacitor, inductor. You might think like, oh crap, what am I gonna do, right? But it's actually very easy. So when things are at steady state, we can negate a lot of those elements. So if I'm gonna draw this over again, inductors, okay, maybe I should add this too. If anybody can tell me what happens to inductors at steady state.
Short circuit.
Short.
There we go, yeah, cool, short circuit. And for capacitors, we get an open circuit. So if we redraw this, I'll try to redraw this as fast as I can. Okay, that's 6 ohms. Okay,
Mm,
does everybody understand how we got there?
yeah. So
Right,
they're
okay.
like,
Because this
Yeah.
shorted right here, and this opens, and this shorts right here. So that just turns into a very simple circuit now. You see? Okay, so now we want to find the current flowing through the 3 ohm resistor, which is pretty much just the current in this loop. If we were to just find the current in this loop, everything's gonna be okay. All right, so however you guys want to do it, I'm just gonna do mesh because that's what's easy to me. Okay, you don't even have to do mesh actually here. You could just do simple Ohm's law, okay? So the current is gonna be equal to the voltage, which is 24, over the sum of the resistors in that loop. And the sum of the resistors are gonna be 2 resistors right here. So what we got is 3 ohms plus 6 ohms. That is going to give us 24 over 9. And that should give us something around 2.67 amps. And do we have a 2.67 amps? Yes, we do. So that is answer B. Any questions on that?
Nope.
Good. Okay, I'll continue. All right, number 14. This one's a little interesting. What's the energy stored in the capacitor? So we just have to base it off the equation, or the formula, I should say. And the formula for that would be 1/2 capacitance times voltage, okay? So you kind of have to resort back to the original circuit in this case. So if we're gonna look at this original circuit here, okay? If we wanna get the voltage for this capacitor, does anybody know how we get that voltage? Any hints? No? Okay, well, it's pretty much the voltage at this node right here. So if we know the voltage at that node, we're able to solve what are pretty much what we need for this equation. So if we get the voltage at VA, okay, oops, I'm sorry, I should say you have to get the voltage across the capacitor, right?
Mm-hmm.
So in order to get that, we have to find VA and find VB. So finding VA, okay. If we take VA, and we already have the current from last equation, I mean from the last question. So that's just gonna be here, maybe I should do this. OIR, which is 2.67 amps times the resistor, 6 ohms. Okay, because VA is simply just the potential difference from that point to ground. All right, does everybody understand that? Any questions? No questions, I'm just gonna keep moving. All right, so we got 16 volts there. And you now have to find the voltage across VB, I should say. Does anybody know what the voltage of VB would be?
0?
0, yes, it is 0. Does everybody understand why that's 0?
Not a complete circuit.
What happened?
Not a complete circuit.
Oh, yeah, you can think about it that way. And pretty much, yeah, there's no voltage after that point. Okay, so now if we set VA, VAB, which is the voltage across the capacitor, and VAB is just VA minus VB because of just the voltage difference, we get 16 volts minus 0 volts, which is just going to be 16 volts. Okay. And if we plug these values back into our equation here, where this is VAB squared, we get 1/2 times our capacitance, which was, I think it was 4 microfarads.
Yeah.
And then times 16 volts squared. If we get to a number crunch, we get something like 512 times 10 to the -6 joules. All right. And that's one of our answers, which is answer C. Question?
Yes.
What's up?
What happened to the 3 ohm resistor?
What happened?
For VA, how come we don't take into account the 3 ohm resistor?
Because we're looking at the voltage what's the word? What was I saying? The voltage, the potential across, or pretty much from this node to ground. You see where I drew that arrow?
Yeah, I see.
Yeah. So if you want the node voltages, so we wanted the node voltages from that point to ground. And if this was ground right here, as it's stated in the diagram, that is going to be our reference. So whenever we're getting a node voltage, we always want to compare that point to the reference. And since our reference was 0 in that case, that's why we had to choose that resistor. You wouldn't go around and do it from that way. That wouldn't be the right way to do that.
Okay, that makes sense. Thank you.
Any other questions? No? Cool. All right. Now, what are we looking for next? 15. What's the energy stored in the 2 ohm inductor? So they give us inductance, which is 2 ohms. And this is just another formula. It's very similar to what we were just using. Oh. But it's just L times I squared. So we have to find well, we already have inductance, so all we have to do is find the current. Okay. But since it's talking about the 2 Henry inductor, if we look at the diagram and we want the current for this inductor, we already found it in the previous problems. And it's just that current that's going through there. Mm-hmm. And since the rest of it is open over here, we don't even have to worry about that. So in that case, it's as simple as just plugging in that current that we found before, which is like 2.67 or something.
Yeah.
And what is that? It's like 7.13 joules. And the closest thing to that is A. Any questions there?
No, easy.
Pretty simple, right? Pretty simple. Okay, moving on. I think I had next was 24. Okay, let me get the picture here. Whoops, okay. All right. Another steady state circuit. All right. So all components are ideal. What is the magnitude of the current in the 20 ohm resistor? Okay, so the 20 ohm resistor, it's given, it's stated where it is. Let's redraw this circuit in the steady state form. So if we were to do this, we got 5 ohms. I like to redraw the voltages like that. I don't know, it helps me. Maybe someone has a different idea, but that's what I like to do. Okay, here's our resistances. This is a 200 volt. This is a 40 ohm. Okay, and once again, we have a capacitor down here, but I'm not going to include it because it is a open circuit, okay? Mm-hmm. Because this is at steady state. Remember, the circuit is at steady state. Always read the question before you keep going. Okay, and we want to find the current going through here, okay? So right off the bat, this is an open open circuit, so no current is going to be going through there. You just completely ignore that, okay? And all you're left with is finding here. You could even just erase it. Do you guys want me to erase it? Or you want me to leave it there so you know?
Leave it there just in case.
Just in
Leave
case.
it.
Okay. Okay.
Yeah.
Okay. So now you pretty much have to do just two mesh equations. So let's say this is I1 and this is I2, and we want to find I2. That's our primary goal. Okay. So so just assign polarities now since you're doing mesh, or you can do whatever. Doesn't matter where you put your polarities. Could be opposite of what I'm doing. Just how I'm gonna do it. Okay. So now find your two equations. So for the first loop, so loop 1, and I'm gonna say this is loop 1. Okay, so we got rise on this side, so that's gonna be, and you always have to check your passive, non-passive sign convention. Be sure to always check that. So I'm gonna get negative I1 times 40 ohms. I'm gonna omit the ohms right now, just because it's annoying. Okay, that's a rise, and then the rest are drops. So that is gonna be equal to 100 plus 200. Okay, does everybody understand that? Are we good there?
EIR.
Good, good.
Yeah, right.
Okay.
Yup. Yup.
Oh.
Chill out,
Okay.
chill out.
Okay, so from there, we can solve that a little bit. We can get negative 40 I1 is going to be equal to 300. I1 is going to be equal to, what is that? 300.
Negative 7.5.
All right, negative 7.5. Cool. All right, that is one. That is one current. Okay. Now, we could just use that current to find our next current. So I'm not even going to use this other loop right here. I'm not going to use that other loop. There's no point of even doing that. All we have to do is make a super loop around, because we can do that. So this is for loop 2, I guess. Okay, so starting from here, this is going to be a drop. Oh no, yeah, this is a plus to minus. Yeah, it's a drop and a rise, then a drop, then a drop, then another drop. Okay, so let's do it. So starting from the, we'll just start from the left resistor on the side. That's going to be negative I1 times 40. Okay. That's going to equal to I2 times 5 plus I2 times 10 plus I2 times 20, and then plus 200. Okay. Are we cool there?
Yep.
Yep, good. Okay, cool.
Mhm.
Okay, so now we got negative 40 I1 is equal to, okay, so what I'm gonna do, I'm just gonna kind of skip this step. I'm gonna sum all these together. So that's gonna give me, what is that, 35 I2 plus 200. Okay. All right. Now you're wondering, oh, we have two variables. What are we gonna do? We already found I1, so we're just gonna throw that. Oh crap. We already found I1, so we're just gonna throw that guy in there. So then we're gonna get negative 40 times negative 7.5 is equal to 35 I2 plus 200. Okay. 7.5 times 40 is just going to give us 300. 35 I2 plus 200. Subtract that to the other side, divide it out. You're going to get I2 is equal to 2.85 or something. 2.857. Okay. And that is our current going through the resistor. And that is answer B.
Sebastian, I got a question.
Yes.
So, I mean, correct me if I'm wrong, but wouldn't we have been able to just do like the I2 loop with 100 volts, 5 ohms, 10 ohms, and 20 ohms and not worry about I1? Will you
Oh,
get the
yeah.
same answer, right?
Yeah, you probably could. I didn't even try that, but yeah, I guess you could have.
What was the other method? I'm sorry. I
So
couldn't
he
hear that.
say, like, don't even do all this BS. Just do this. Okay, here. We'll do that. We'll show everybody that you can also do that.
Okay.
Yeah, it's always good to find the simpler way. So, okay, this is the alternative method. This is the good way, I should say. Okay, so you don't waste a lot of time. Okay. We're just going to do this loop. Okay.
Mm-hmm.
So just doing simple KVL on that, we get 100 is equal to 5 I2 plus 10 I2 plus 20 I2. And look at that. We get 135 I2 and we get the freaking answer.
Save some time.
There you go.
Devin
Yes.
said he wants to be a professor as well, bro.
Yep, there you go.
I'm tutoring, so I'm getting there.
Mm.
That is the good way. So screw everything I just said, because that's going to waste you so much time, and this is the way to do it.
I like
All
it.
right.
I like it.
Any questions?
That's what Tabrizi is, bro. 20 lines turns to 2 lines for her.
Yep.
There it is.
I found things that were totally unnecessary, and I overcomplicated it. And such is life.
Such as Tabrizi's test.
Okay. All right. Moving on. Last one. Another one that will overly complicate, but hopefully not.
I have a question on that one,
Yeah.
on this problem. So, let me see. Did we really need to find I1?
No, in reality, you didn't. Because the thing is, there's already a voltage source right here. If there was a resistor right there, then that would have been a problem. Because now you have 2 equations and 2 unknowns. And you would have to go through that route that we initially did. But giving a voltage right there actually gives you the answer. Because also remembering that this whole leg right here is gone. Get what I'm saying?
Yeah. I get you.
Yeah.
Okay.
Yeah.
Just making sure.
Yeah. But that was a good way. Thank you for pointing that out. That was probably in the solution and I didn't even check it because I'm stupid. Okay, moving on. Last one.
25.
Oh, whoopsie. I already spoiled it.
It's okay. I wouldn't get it either way.
Okay. I think this one should be, everybody should be able to do this in their sleep, but if you can't, here we are. Let me make this a little bit smaller. It's kind of fried, I know, but I just had to copy it from the thing. Okay, so redraw this. Okay, we got minus plus 20 volts. Oh God, I'm drawing this super ugly. I'm sorry. Hold up. All right, so we got current A going through that way and current B going through the other way. This is where you have to be really good at your passive sign, non-passive sign conventions, because if you don't, you're gonna get cucked. Okay, so first thing to do, since we're doing mesh, they give you the way the currents are going, assign polarities. Okay, and then do simple KVL. Okay. So first loop, what we got here is we got a rise. They're all rise, so they're all going to be on the same size. Same side. So you're going to get negative IA minus IB, all that multiplied by 8 ohms, plus we got negative IA times 12 ohms plus 20. That is all going to equal 0. Are we cool on that? Yes. Okay, cool. Let's keep going. All right. So if we solve this out, we get IA minus, oops. Okay, we're going to keep simplifying because we have 2 of the same right here. We're going to throw those together and we're going to get negative 20 IA minus 8 IB plus 20 equals 0. Okay, that is equation 1. All right, put that to the side. Let's do the other loop real quick. So we got, excuse me. We got same thing, IA minus IB times 8 ohms plus 40. Okay, simplify this a little. Okay, cool. Now, we could do this one of 2 ways. We can substitute or what's the other way? Elimination. How do you guys want to do this?
Elimination.
Elimination? Okay, cool. I want to do that too. Okay, so elimination, putting them right on top of each other and seeing what happens. So we got negative 20 IA minus 8 IB equals negative 20 over negative 8 IA minus 8 IB equals negative 40. Oops. Okay, put that one over the other. Oops. I would say multiply, I don't know, this by negative 1. That way we get negative 12 IA, and these would cancel out right here. And you're going to be equal to 20, I believe. Yeah, 20. Okay. So then IA is going to be equal to, what is that? 20 over 12. About 1.667 or something. All right, now we just plug that bad boy back into one of those equations and we got our answer. I think the exact is like 5 over 3 or something.
Mhm.
Let's use the exact. Okay. What is that? times 8 is 40 over 3 plus. Sorry, I'm just doing math right now. We got like
20 over 3, I think.
160 over 3, whatever.
Oh.
And then we're going to divide that by 8. And we get 6.667.
Whoa.
whatever.
Can we also do this by superposition?
Sure. We could totally do it by superposition. Do you want to explain how we do that, Justin? Or
Should I do it on my paper? Should I annotate? Like, what's?
Oh, you can annotate, or maybe that's probably easier. Or what do you think? I can erase it for you. Does everybody understand that? Did everybody get that last part?
Yeah.
Yeah, I understand
Yeah.
it.
Cool. Okay. Okay. Maybe I should here. I'll give you some room, Justin.
Just shift everything down.
Go ahead. Go ahead.
Oh,
You got some white space there.
that's why you have a 3 point something.
Explain this real.
7.
Yeah.
So basically, we're just gonna kill sources and do sources one at a time. So like, let's say we're gonna do this one to find IB, kill this source, and now we just have this whole mess right here, right? This is just gonna be minus, plus, and then resistor, resistor, pretend they're all connected, right? And this will simplify to 40, these two, 8 in parallel with 12. That's gonna be 4.8. You do, and then your IB is gonna equal 40 divided by 4.8. It's gonna equal 8.33. 3. Excuse the handwriting. 3. Now you're gonna do the same thing for the other one.
Justin,
Yep.
before you move on, I have no clue what you're doing.
Oh, okay. So basically what I'm doing is I'm just killing the source. So like what happens if you kill this, right? What do you get?
20, right?
You get
Yeah. Okay.
20. If you kill the 20, then you just get 12 ohms on the left and then 8 ohms in the middle. And that's, I'm assuming, what those are.
Exactly.
And then on the right, you would have 40 volts. Okay. So then you're just combining them. You're combining the 12 and the 8 in parallel with each other?
Yep.
Oh. Well.
8. It's so bad. Yeah, okay. That's what I'm doing. So I'm just, yeah. And we just found our current IB right here, I think. Sure. And now we can do the other one. We can kill this source. Unless you guys want me to stop or explain or something, but yeah.
I get what you're doing.
All right. So now we kill this source. Right here. That's gone. So now we're just shorting this 8 ohms, right? So it's going to look like minus, plus 20. And that's 12. This one gets shorted right here, right? By this path. You can kind of like just ignore it. So what's the current here? It's just 20 over 12. 20 divided by 12. That's going to be IA equals 1.67. And you just want to find this one right here, right? Going through here. So now we just do IB minus IA. That's going to be these two subtracted IB minus IA, and that's going to give you 6.7.
Yeah.
I don't know if I lost any of you guys because like
Oh,
trying to annotate this is hard.
So, explain to me one more time why you shorted the 8 ohms.
Oh, because like if you kill the 40, right?
Mm.
You just get a wire. Like the 40 is supposed to be right here. This is where the 40 would have been. But now that you replace it with a wire, it's gone. Right? Like what happens if you just run a wire straight through 40?
Oh, it bypasses the 8 ohms completely.
Yes, exactly.
Got it. So my jet engines are turning on.
Okay.
That's just one more way to do the problem.
That's actually a little quicker way, I think. Less math too. All right. Anyone have any questions on this one? We got one more that we said that we were gonna do.
I just wanted to make a little like suggestion to this type of problem. So I remember when we were trying to eliminate some of the variables and we did it by hand. So I was going on YouTube, just trying to find like tips for the FE, and they were saying to utilize your calculator for things like this, like system solving. So I know I got a different calculator than you guys, but I was able to find the values really quickly, which would save a lot of time, you know, for future problems on the actual test. So I don't know if you guys want to look on YouTube or just create a habit for using the calculator like that.
I honestly don't know how to do that, so if you can some clear time, that'd be dope.
Yeah, I mean, I can find some videos for you guys or post it because
You could
I don't have the same.
post those. Yeah. That would be dope.
Just a heads up.
Thank you, sir.
All right. Actually, gotta go right now. But I think that was the last one I was gonna do. So there it is. If anybody has any other questions, just PM me privately later on. But yeah, I'll catch you guys the next time.
For sure. Thank you, Sebas.
I love you.
Appreciate it, dude.
Good night, Sebastian.
Good night, everybody.
Thanks, sir.
Yes, Sebas.
Thank you.
All right.
Good night, Toa.
What's up? Matthew, you want to throw up the 32?
Yeah. Give me a couple of seconds, guys.
Anyone hear music in the background? Yes, no?
No.
Nope.
Okay, cool. Just making sure.
I hear something coming from Felix though.
You what?
No, I said I heard something coming from Felix.
I don't hear anything. Which one are you doing, Matthew? 32?
32, yeah.
Okay.
So it looks like we got a 40 volt voltage source, 2 ohm resistor. It's a 4 ohm resistor. And another 4 ohm resistor in parallel.
Mm-hmm.
Okay, so the problem is asking for the current through the battery. Okay, so the first step in solving a problem like this is just finding your equivalent impedance. Luckily, this one's pretty easy. We have these two in parallel. And as you guys know, there's a shortcut. When you have two resistors in parallel that are the same value, the equivalent resistance is just going to be half of one of those resistor values. So in this case, because we have a 4 ohm resistor in parallel with 4 ohm resistor, it's just going to give us 2 ohms. Everyone understand that?
I didn't know that, or I don't remember. I never remembered that, but yeah.
Yeah, it's a super helpful little shortcut.
Yeah.
All right, so always get in the habit of redrawing. If you have the time, then definitely redraw the circuit. It helps. So now we have a series combination of the 2 ohm resistor and this combination of the two 4 ohm resistors in parallel. So the last step is just a simple Ohm's law. So this current is going to be equal to our voltage source divided by the sum of those two resistances. So it should be 10 amps. Pretty simple.
Nice.
Easy.
Yeah.
Anyone have any questions, concerns? Everyone's good?
No, I'm good. Yeah, I'm good. That one was simple.
And with that's
All right, that one was pretty simple, so I'm pretty sure no one has questions on that one. So moving on.
moving on. That was pretty much, I believe, all the questions that we were gonna go run through. However, if you guys did want to do a little more practice, there is another problem that I can put up and we can
Yep.
try it out.
Mhm.
Do that? Okay. Mhm.
You guys can continue from here. I'm pretty gassed right now.
Yeah, no problem, dude. No problemo.
Sure.
Alrighty, you guys
Thank
have
you.
a
All right, man. Thank you so much, Matthew.
Good night.
Of course.
Peace, man.
Thank you, Matthew. Good night.
No problem,
Bye,
guys.
dude.
Have a good one. See you in the next time.
For sure, dude. Night.
Night, guys.
Good night.
All right, so I can do this one right here, actually. Number 31. I didn't realize it was a steady state problem. You guys want to do something like this? A lot of these are actually circuits 2 problems as well. So if you guys want, you guys can, there's 31 right here. I don't know how to,
We can try to attack it. I mean, I think Sebas has been emphasizing like steady state, what to
Yeah.
do
Mhm.
with the inductor and the capacitor.
Yeah, absolutely.
We can try to attack that one. Which one is it? 31?
31. Now the solution's right here, so y'all,
Oh shit, it has an AC source, huh?
Mm-hmm.
yeah,
Scary. Just
What y'all
kidding.
gonna do? What y'all gonna do, huh? What y'all gonna do to the AC source?
I'm just gonna kill it just because. I'm just kidding.
I don't know what to do with that AC, man.
I honestly think that you just get rid of the
Let's see.
isn't there a formula? No, not a formula, but is
Didn't that go to an angle, the cosine? That's what he's looking.
No, you can't do phasor because there's no
Oh, it's phasor.
no
okay.
whatchamacallit. There's no frequency in the
The
DC.
Isn't there a DC part of it though? Isn't the 20 the DC part? So you just keep the 20, right?
No, 20 is it's the V max. It's the amplitude.
Steady state.
Fucked for this time.
Wait, it says what is the current through the inductor, and that inductor it actually gets shorted, right? So
Mhm.
if there's nothing, then that means
Doesn't, because there's an AC source.
Oh, it does.
There is a DC source as well though.
It is, but like, okay, so the DC source it pushes it through, right? And the AC source like makes it go up and down as well. Yeah, especially because it's 20, right? So it's going to be negative at some point. Oh, no, I don't. Never mind. I don't know how to do it. I was thinking that you have the 20, right? And 12, and you just push it right down, but they're not in series. Superposition. There you go. I think we do superposition.
Can you do like no? Maybe like DC is, I don't know. Like, should we only look at the right side then? Because it's like only look at the DC part of the battery.
Let me try something first. Let's see if I can. Where the fuck's my pencil? Wait, you're recording this, right? I shouldn't curse.
Oh yeah, I forgot.
Our video is gonna get flagged.
Throw me out.
Oh, is it really? Oh my god. You think? Oh, okay.
Gonna be age appropriate.
All right. So
You make this for adults only.
12 cancel out. What's 12 divided by V over I? 10 equals 1.2.
It actually stops sharing this part of it.
Is the answer D?
Let's go ahead and check. No.
Oh, fuck.
What is it?
I mean,
Fluff.
fluff. Oh, fluff.
We need an editor just to make a noise whenever we curse.
What's the answer, Anthony? Which letter?
It is
0, huh? Just kidding.
It is one of the 4 letters.
Oh God.
Oh, like that one.
That helps.
Yeah.
What is it?
Oh, it's C.
The answer is C.
Because look, I was thinking.
Good job.
I was thinking.
So you do only look at the right side, no?
Yeah, I was thinking we can kill the source, the AC source, and then that gets rid of the 5 ohms.
Yeah.
So since it's steady state, the inductor will go to
Short.
what is it called?
You short
Short circuit, and then you do I equals V over R, which is 12 volts over 10 ohms, which is 1.2. And
Yeah, I
that's
think
the
the keyword was DC, right?
Oh, DC current. Never mind. Okay.
So then you only look at the right side then, like what you were saying, Kim?
Yeah, I'm assuming because it says DC and left side is, it clearly has like the AC, like, you know, the wave. And the battery to the right is just DC. So that's my guess.
I think you're right, Kim. Also, average for an AC is going to be 0 because it's oscillating.
Oh yeah, there is no DC current in the AC.
I don't like this problem. This problem tricked me.
Anthony, can you like do it on your iPad since we already kind of solved it, but you know, so we could all write it?
I can. I don't have the brain power to like do what you guys are doing. So like I'm gonna be lost while I do it. But I mean, if you guys are cool with me being lost, like while I try to go through it. Then.
Do you guys want me to do it really quick?
Yes.
Okay, wait, leave it right there so I can screenshot. Okay. Let me share my screen. Once you... Okay. Oh, can't believe I made it this far. I'm just kidding. Okay, so basically, my guess was what is the DC current? So this is a keyword, and then it's also a steady state. So we know again what Seva said. When it's steady state, we short the inductors, whatever, and then we open capacitors. You guys can see my screen, right?
Yes.
Yes.
Okay, so this is AC and this is DC. So because the keyword says DC current, for this, we only look at this part of the side. So we're gonna redraw. And then we said that because it's steady state, we're going to short the inductor. So do you guys want, or
Yeah,
I'm just gonna short it. Okay.
Yeah, just run a line through.
Yes.
Okay. Then from there, we just have 10 ohms, and then it just says like basically find the current here, which is basically everything. Yeah, right. So find I.
12 divided by 10 is 1.
Yeah, so V equals IR. So 12 volts is equal to I divided by 10. I is equal to 1.2 amps. So I don't have nice writing like the guys, and I'm a girl. Okay.
It's okay, Kim. Did you see my writing?
All right. So there you have it. Any questions? Anyone?
Yeah.
Okay.
No.
Yes.
All right. Do you guys want to go ahead and start up the next one, or you guys? How's everyone feeling right now? How's everyone feeling? That's what I want to ask. That's my question.
I'm good for a while.
Gassed? Anyone else gassed? Ready to go to bed, or are we ready to keep pushing forward like soldiers?
Pushing forward.
Shoot, dude. Let's go. All right. Say less. Say less. I believe there's something we haven't. A lot of this is circuits 2. So I need to find one. Give me a quick second. I don't know if we did 22 already. Yeah, can you tell me?
What's 22?
Can y'all tell me if we did this one already? 22 already? Show you right now. Oh, this one.
No, that one's pretty simple though.
You're just kind of combining all the capacitors, right?
Yep, it's 40. Because you just add them up together because they're all in parallel anyway. So
Except for these two. Just kidding.
divide those in two, but they're the same, so you can just divide by 2. You get 5.
Oh crap! You're right. I already forgot Matthew's shortcut. Damn it. A lot of these seem pretty straightforward. Like this one's pretty straightforward. Total capacitance. These are all in series. So half of this is 1, half of this is 1. Add them together. No, you don't add them together.
Also, you don't have to do the math. You can just A is the only one that's less than 2 picofarads because it can't be greater. So. Ooh, that electronics problem up top.
Oh, this one up here? Dude, I don't even know if I want to dive into stuff like that, bro.
That's a formula you just gotta find.
I didn't even see the problem.
Pull up the problem if you guys.
It's in the handbook.
And also, these are mostly circuits 2 problems right here. All these. So you got the switches here. Sebas knows all about these switches. But I mean, we did 26 already. We did 25. And we did 24.
Yeah, we've done like most of them.
We did most of them. We
Like
did
all of the non-circuits too.
pages full of
Almost.
them.
Anyway, I feel like we did.
We did.
For next session, can we do something besides circuits?
What's up?
For next session, can we do something besides circuits?
Absolutely, bro.
I was gonna
Anything
ask on that. I got someone who replied to my story because I posted like our session. And they asked me like, how are we gonna do this? Like the topics. Do you guys have like a format or like agenda or something?
So that was
Alright.
kind of the point of us taking the test with what you call him? With Chef.
Oh, okay, on Friday.
Yeah.
Friday.
So we wanted
Okay.
to take the test and we wanted to see where our weak points were, like our biggest weak points, and then we'll go from there. You know?
Got it.
So for Thursday, we're still gonna do circuit.
So for Thursday, we're
Oh.
most likely gonna. I'm thinking because Seba said that he.
Let's do controls or something.
Yeah, I'm down for control. Something. Let's do what you call it? I know Johnny's taking probability. We can throw in some probability.
Mm-hmm.
Yeah, we can do
Yeah, 'cause
prob
I-
EMF. Let's do it.
I scanned the probability, Anthony, from the book that I have, so I can just send
did
it to
you?
you and you can use those. Yeah,
Wonderful. Yeah. Then yeah, if you can do that, then.
I scanned like 8
Probability.
chapters so far.
And like when you're doing EMF and stuff too, like if you draw it with unicorns and oranges and things that aren't like traditional math
And
symbols. it makes sense.
pandas.
Yeah, and pandas.
Anthony,
Honestly, I think I can stop this recording then, because I think we did mostly all of them. And then if you guys want to tackle the circuits 2 problems right now, I have no fucking clue how to do.
I think we need
Or-
Sebastian. Sebastian needs
or-
to save us.
for Thursday, can we do half of the session controls and the other half probability?
Yeah, absolutely.
We're doing like 1 hour and 30 minutes today, so we can do like 45 minutes one, 45 minutes the other one.
Go ahead and stop this recording.